Hello everyone, this is Kalpana here. In this video we are going to see a problem from partial differential equation. So let's get going. Problem. Eliminate the arbitrary function f from z equal to f of y by x and form partial differential equation. So we are given an equation z equal to f of y by x and we are asked to eliminate this f and also to form partial differential equation. Given z equal to f of y by x, consider as some equation number 1. Now let's partially differentiate it with respect to x. Partially differentiating 1 with respect to x. Okay. We'll apply dou by dou x on both sides of 1. This gives us dou z by dou x equal to partial derivative of f of y by x is f dash of y by x into inner derivative, that is dou by dou x of y by x. Since we have a notation dou z by dou x equal to p, let's replace it by p. We'll get p equal to f dash of y by x. Since we are partially differentiating with respect to x, so we'll treat y as constant. Here y is constant and we'll write this term as dou by dou x of y into 1 by x. Okay? Or we'll just take this constant out, I mean outside the brackets. Okay, fine. We'll get p equal to y into f dash of y by x into partial derivative of 1 by x with respect to x is minus 1 by x square. Right? This gives us p equal to y into minus 1 by x square is minus y by x square into f dash of y by x, or bring this minus y by x square to LHS, you will get minus p x square by y equal to f dash of y by x. Consider as some equation number 2. Now partially differentiate 1 with respect to y. We'll apply dou by dou y on both sides of 1. This gives us dou z by dou y equal to partial derivative of f of y by x with respect to y is f dash of y by x into inner derivative. Since we are partially differentiating with respect to y, so we'll treat x as constant and here z is a dependent variable. Okay, fine. Now we also have a notation dou z by dou y equal to q. So we'll replace dou z by dou y by q. We'll get q equal to f dash of y by x into, here we'll write y by x as, we'll just split it, into y into 1 by x, because here 1 by x is a constant. We'll write this as one by x, which is a constant. We'll take it outside the brackets and we'll write it as 1 by x into dou by dou y of this y, which gives us q equal to f dash of y by x into 1 by x into partial derivative of y with respect to y is 1. This gives us q equal to 1 by x into 1 by x into f dash of y by x. Or we can write this as, now bring this 1 by x to LHS, you'll get qx by 1, which is qx equal to f dash of y by x, right? 1, no problem. Consider it as equation number 3. Observe 2 and 3 into you're having minus px square by y equal to f dash of y by x, and in equation 3 you're having qx equal to f dash of y by x, right? Now we are going to eliminate f dash of y by x from equation 2 and 3 with the help of 2 by 3. Minus px squared by y by qx by y equal to f dash of y by x by f dash of y by x. LHS of 2 by LHS of 3, RHS of 2 by RHS of 3, right? This gives us minus px square by y into 1 by qx equal to, cancel these two, we'll get 1, which gives us minus px square. Minus px square into 1 is minus px square, y into qx is qx y equal to 1. You can cancel 1x, then you'll get minus px by qy equal to 1, which gives us minus px equal to qy, or we can write this as qy equal to minus px. Now bring this minus px to LHS, we'll get px plus qy equal to 0, which is the required partial differential equation. Which completes the problem. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.